If you remember, in the past videos, we have studied the properties of an image formed by concave and convex mirrors. What about the lenses? Do lenses also form images? Yes, they do. And just like spherical mirrors, their properties also vary with the object's position. In the last video, we discussed two types of lenses, a convex lens and a concave lens. So how do the images formed by these two lenses appear? The two properties of the images that we are interested in are its size and its nature. Okay, so this is our convex lens, and suppose initially our object is kept at this position away from the lens. We will make a table on the right with 3 columns in it, just like we did for spherical mirrors. Now before filling up our table, I want you to concentrate on this part first. For this position of the object, where will the image be located? Well, the image will be formed here. Yes, on the other side of the lens. Now obviously your first question will be why? Well, the position of the image depends on the way light bends after passing through the lens. You're going to learn this in your higher grades, so we're not going to discuss where the image is located. But then you will ask, how can we know that the image is formed here? This is simple. If you keep a screen at this location, then you will get the sharp image projected onto it. This tells us that this image is formed at an actual location in space. Tell me, is this image real or virtual? Since this image can be projected onto a screen, it's a real image. This is the definition of a real image. And we also know that a real image is always upside down. What else can you observe in this image? Can you say anything about its size? Yes, its size is same as that of an object. So when the object is at this position in front of the lens, the image formed will be of the same size as the object and it will be real and inverted. Let's name this point C. What will happen to the image if I move the object along this line? First of all, there are only 2 directions in which I can move the object, either towards the lens or away from the lens. Now observe what happens to the image as I move this object away from the lens. You see that as I move the object away, the size of the image keeps on reducing. Its size is lesser than the object beyond C. However, the image maintains its nature. It always appears real and inverted beyond this point. This is exactly what you will also notice in an actual convex lens as well. There will be a particular distance from the lens at which the image will be real and inverted, and its size will be the same as that of an object. And also beyond this position, the size of the image will keep on reducing, but its nature will be the same. What will happen if I move the object towards the lens from this point? Again, look carefully what happens to the image as I move the object in this direction. The obvious thing that you must have noticed is that the image appears to be bigger in size compared to the object. The image is also upside down. This means that the image is still real and inverted. Keep moving the object further ahead and you will find that some point image will be huge in size. Yes, at this position of the object, the image formed will be highly enlarged. Also, the image will be real and inverted and positioned very far away on the opposite side. This point is given a name and it's called a focal point. So when any object is kept at a focal point of a lens, its image will be highly enlarged. Now let's move the object further towards the lens. Did you get surprised? The image is now formed on the same side of the lens. Also, the image is straight. What does this mean? Yes, it means that this is not a real image. This is a virtual image. It means if we bring a screen at this location, then this image cannot be projected onto this screen. You will also find the size of the image to be more in this region. However, in comparison to the object, the image will still be much bigger. Okay, so we saw these many cases for different positions of the object. Now I will bring each case individually in front of your screen. Pause the video and go through each case once again very carefully. So what can you say about the properties of the image in a convex lens? This table represents the properties of the image formed by a convex lens at different positions of an object. Okay, so this was all about a convex lens. What about the concave lens? How is an image formed in a concave lens? I will quickly tell you about the image properties in a concave lens. This is our concave lens, and we will initially keep our object close to the mirror. For this position of the object, an image will be formed here. I need not tell you that this is a virtual image formed on the same side of the lens. You must know it by now. What else can you say about the image? It is smaller in size compared to the object. Okay, now watch what happens to the image as I move the object away from the lens. You see that the image's size is decreasing even further. Also, the image maintains its virtual nature. Will this always be the case? Yes, the size of the image is always smaller than the size of the object in a concave lens. Also, the image in a concave lens is always virtual and erect. So the properties of an image in a concave lens are very simple as compared to the properties of an image formed in a convex lens.